Today, let's look at the galvanic cell system. So this is an example of a galvanic cell where you have your copper as your cathode and your zinc as your anode. Okay, so your cathode will undergo reduction, your anode will undergo oxidation. Okay, so over here, okay, your schools will teach you to do E0 cell equals to E0 reduction minus E0 ox. Okay, but I'm going to show you an alternative method. Both are accepted at A level, Cambridge. So what you do is this. Okay, so copper 2 plus 2E becomes copper. The E0 will be plus 0.34. Zn2 plus 2E, which will give you Zn. E0 will be equals to minus 0.76. Okay, so this represents the E0 reduction. Okay, what you need to do is choose the most positive. So the most positive is always preferred. Okay, which means the copper reduction is more positive, which means this will be preferentially reduced and the zinc will be oxidized instead. So what you need to do is just reverse the equation. So you get zinc becoming Zn2 plus 2E. And when you reverse the equation, you come up with a new E0 called E0 ox, where you reverse the sign as well, plus 0.76. Okay, technically E0 is defined for a reduction potential, but for purposes of solving this, it will work just as well. Okay, and in fact, I prefer this method because it's easier and more convenient to remember. Because A minus B and B minus A is different, whereas A plus B versus B plus A is going to be the same thing. So that is a lot easier to remember. Okay, and it's a lot easier for you to understand and show clearly which one is undergoing reduction and which one is undergoing oxidation. And for this method, you only need to remember that the most positive, either for oxidation or reduction, is always preferred. Okay, so once you have gotten your E0 and your E0 ox, all you need to do is add them together and you get your value. So if it is positive, it means that it is energetically feasible or spontaneous. They have the same meaning. Okay, now I just want you to remind yourself, where have you seen this terminology before? You've seen it in chemical energetics part 2. Okay, where we talk about your delta G. Okay, so is there a relation? Yes. Okay, your delta G is related to your E0 cell. So by this equation here, delta G equals to minus NF E0 cell. So therefore, as you can see from this equation, if E0 cell is positive, your delta G will be negative. So when your delta G is negative and your E0 cell is positive, they mean the same thing. So they both mean that your reaction will be spontaneous or it will be feasible. Okay, if your E0 cell is negative, it will be not spontaneous or not feasible. Okay, so it has the same meaning. Your delta G is related to your E0 cell. So similarly, your E0 cell will not be able to predict whether the reaction really occurs. It only predicts whether or not it's spontaneous, because the E0 cell only gives you an indication of the thermodynamic feasibility, but not the kinetic feasibility. Meaning, it could be thermodynamically feasible, meaning you do not need to input energy for the reaction to occur, but it could occur so slowly that in reality you do not see it occurring in an appreciable rate for you to observe. So as far as we are concerned, the reaction did not really proceed. Okay, so for example, the conversion of diamond to graphite is supposed to be a spontaneous process, but it could take very, very long for that to occur. So therefore, it's not kinetically feasible, and therefore the reaction does not really proceed in reality. Okay, so this is the difference between kinetic feasibility and thermodynamic feasibility. Okay, so this is how you calculate for E0 cell. This is 1 minute of chemistry. I'll see you the next time.